Traditional SD-WAN ensures that business-critical apps get the best performing network path to deliver a good user experience and meet service levels. But as SaaS and cloud adoption increase, the best path across WAN may not be enough. We've had techniques like WAN optimization and legacy caching that may have worked for enterprise or private apps, but SaaS and cloud apps are designed differently. So what's the right approach? On today's Tech Bites, we talk with sponsor Palo Alto Networks about how they're incorporating application acceleration into Prisma SD-WAN and Prisma SASE to deliver SaaS and cloud apps with the highest level of performance. Our guests are Subbu Varadarajan, Senior Director of Product Management, and Mitesh Patel, VP, SASE Go-to-Market. Subbu and Mitesh, welcome to the podcast. And so is there something about the way cloud and SaaS applications are developed that impacts performance?
First of all, Drew and Ethan, it's great to be back on the show. I love the podcast that you guys do. It's pretty informative to the audience, and it's a pleasure to come back and discuss app acceleration. And to answer your question around how the SaaS apps are designed, if you think about it, SaaS apps, the primary reason customers go for SaaS app is they don't have to manage them. They don't have to worry about scaling. All they have to do is just use the service, and it's great for them. The problem is if there is a problem with the SaaS app, if there is a performance problem, they don't control these apps. In other words, these apps are happening in perimeter that's outside the level of influence for the enterprises. So the way we want to think about enterprises, our customers, is how do you empower them? How do you give them control in terms of visibility? How do you give them control in terms of application performance? That in spite of whatever occurs on the other side of the fence, they're able to deliver the best performance.
From a networking perspective, like you mentioned, back in the days, we used to use WAN optimization. And how has that transformed to today's world? Well, 10, 15 years ago, when we employed WAN optimization, we were 100% solving for workloads that sat within our data center. And we were typically seeing applications like CIF, NFS, file sharing, so things like that, or chatty protocols. And we wanted to obviously push more on MPLS circuits. We were low bandwidth circuits. And fast forward to today, we live in a ubiquitous world where applications are anywhere, SaaS applications like Subbu mentioned, cloud workloads, as well as you still have the legacy apps still sitting in on-prem data centers. So from an SD-WAN world, we basically came to the market to solve for a business problem where customers were challenged with basically providing that level of resiliency and that multipathing capability across all those different workloads. And so from a networking perspective, how do I solve for the latency issue, and where is the latency issue? Do we even know where it is, right? Historically, we've always assumed it's on the carrier circuit. And today, more so than ever, as customers have moved off of MPLS onto internet circuits, the trust of any sort of SLAs given on internet circuits has gone out the window. And so today, that problem statement is even exacerbated because the assumption is always the first hop, because the last mile or the first hop out of a branch is the section of the network that nobody has any control over, neither the carriers nor the customers or anyone else. And so we used to employ protocols like FEC and packet dupe to address that last mile issue. Now, the challenge with that, just like WAN optimization, is that it's a bookended architecture. So you really have to have the same technology on either end. Now, but what if from an SD-WAN perspective, I have the flexibility of going directly out to the internet. And yes, even going directly out to the internet, I also want to employ some sort of cloud security solution, and therefore I may go through some SSE solution to get to my application. But what happens with network resiliency and conditioning? I lose that functionality. And so this is where working with Subbu and team from a product standpoint, we really went out to go and solve for that missing link, right? Because there's really 3 or 4 legs to this problem statement. There's the LAN network with wireless switching, something could go wrong there. The last mile, something could go wrong there, and it always has in the wide area network world. The middle mile, which is today, it could be a carrier network. Some customers use companies like Equinix and Megaport, and others use SSE solutions. So there's that middle mile. And then the first mile where the application sits, which is what Subbu was talking about just now, is where we literally have no control anymore, especially with SaaS and cloud workloads, where if that application is performing weak and/or is taking a long period of time, or the latency is induced at that side, how do you solve for it? Because FEC and packetable is not going to solve for that. And so when you look at that entire end-to-end transaction, that's been the challenge that customers are faced with. We always assume it's a last mile issue, but it's not. And it is sometimes, but it's not always. And so,
Well,
I know
Mitesh,
Subbu,
the way we solved this back in the
yeah,
day, the way we
yeah,
would have been, we would have taken some kind of a middle box on either end of the connection that would have
yes,
had special protocol knowledge so that it could accelerate that traffic. You mentioned CIFS, SMB, FTP, a variety of things that we might have pushed through that and gotten big benefits out of that. But the magic was we had a box on either end that could effectively encode and decode so that we could get that acceleration. It had the protocol magic. It really knew what it was doing. So it could do the dedupe and so on. But in the scenario you just described, we don't have a middle box on either end necessarily because it's a SaaS service and we don't own what's there in that first mile, for example. So are you talking about the same kind of application acceleration I'm thinking of from WAN architectures of old, but implemented in a different way? Or are we talking about something else really?
exactly right, right. So it's a combination of a couple of things. Back in the days, we used to do TCP optimization, we used to do compression, we used to do caching. Like those were the three techniques that majority of vendors used, right? Or some version of that.
And yeah, and I throw tokenization in there when you
Yes.
really got fancy. Yeah.
Yeah. So that's kind of exactly the problem statement we're solving for, because like I said, there's certain workloads now that customers will deploy using SD-WAN that those techniques don't no longer work. And so I really wanted to kind of dive into that and see how Palo Alto is solving for that. And I know Subbu was going to go into a bit more detail on how we solve for that.
Certainly, Mitesh. And I would say the thing that kind of stood out based on how you guys were characterizing the problem is, Mitesh, to your point, it's important we understand where the latency is, like, or how the latency is distributed. And for me, the North Star has always been you only optimize what you measure. So what we did, even before we jumped into optimizing the problem, end-to-end problem, we actually took the popular SaaS applications that are being used by our customers across the belt, and then we basically maniacally measured how the latency is distributed across the cut. The first mile where is defined as where the applications are running and when they are handing it off to us, right? We define that as the first mile. Then you have the middle mile. It could be the SASE mile. It could be the ISPs. It could be all the things in the middle that actually carries the packet forward. And then you have the last mile where you are handing it off to the client device. And most of the times here you are dealing with packet loss, packet corruption, jitter, and all those issues. And I always want to, this is where we should actually be thankful that the technology leaders that came before us helped us solve problems that are kind of universal in the networking layer. They figured out that you can do like congestion avoidance by figuring out the path that is optimal for latency or throughput. They also helped us with FEC and like a lot of interesting techniques that would combat latency in the networking layer. The problem that was happening now, and I always say this is why you only optimize what you measure, the problem space has shifted now. The latency, when we did our research, it was clear that like 90% of the latency was occurring inside these applications. A good example could be if you have dealt with ChatGPT or if you dealt with any of the newer, heavier applications today, whether it's Salesforce, Workday, all these are ServiceNow, fantastic applications, but they are dealing with large data in the backend. And that means that these applications they are forced to do heavy computation. And that's the bottleneck, right? What it means is, imagine you are ordering something in a restaurant. It's a fancy restaurant. You walk in, you are super hungry. You're ordering something from the chef, and the chef takes like 2 hours to make it. It's a fantastic food, but 2 hours, and you are already starving, right? Yeah, you can enjoy the nuances of the food, but at this point you're turned into an animal, right? So the problem is when there is latency, it compromises experience. And while the developers are doing a lot of optimization, there is a fundamental thing that prevents them, which is computation. And if you're in a reactive world, you can't get ahead of the problem, right? So that's what we tried to tackle in the application acceleration space. What we did was we brought context to the table. We understood, is this person interacting with bandwidth heavy application, or are they interacting with latency sensitive application? Based on that, what you optimize for and how you optimize for can change. As compared to having just a hammer and a nail approach, we now try to bring some nuance to the table. We try to understand what is constituting, what is contributing to the latency, and what we can do to combat it.
So can you drill into that a little bit more? Because if I'm a network engineer, I'm thinking, okay, I am not getting into the Salesforce infrastructure to try to optimize it for my traffic. What can I do with my SD-WAN connection then?
That's a great question, Rup, because if you think about, and if you wear the hat of a network person today, okay, my heart goes to them. If there is a problem, people just go and automatically assume it's a network problem because that's been wired. That has been the problem in the past. And this is what I call availability bias. Because of that, they understand last time this person magically fixed my problem by putting an access point or by increasing my bandwidth. Let me go and complain to the IT person so that they fix the problem for me. So IT person has always been like the hero who can combat all these issues for them. But now the problem space has shifted to, in your example, Salesforce, right? But they still come to the IT person hoping they can solve the problem for them. So the approach we took in Palo Alto was, how do we bring that control back to the enterprises, to the enterprise IT force? And the way we did that was we deployed bots. So every application will have a bot engine, Drew. And the way the bot engine is designed is it literally understands what features are heavily leveraged by your workforce in your enterprise for for all these applications, right? And then it understands how frequently your workforce is accessing what feature set. So then the bots start to create what I call a heat map of if you can chart something between latency, which is or the response time for APIs, to the most leveraged features. What you get is an intersection of what I call like the troublemakers, APIs that are very heavy. So what these bots do, so when say, Drew, you connect to our SD-WAN that has app acceleration, we spawn a bot. That bot is dedicated to you. Let's call that bot Drew bot. The bot doesn't track anything you do, just so you know. I'm just calling it a Drew bot, just for ease of
Thank you for easing my mind about that. I appreciate that.
and say when Ethan connects, we're going to spawn an Ethan bot. This bot has zero allegiance to Salesforce. It has zero allegiance to Palo Alto. It only cares about how do you make the experience for Drew better. That's the only thing Drew bot cares about. And think of the bot as your virtual avatar, right? That's working hard on your behalf. So when you're clicking on Salesforce, this bot would understand the heat map of Salesforce. It understands what features matter to you. And then it is looking ahead to say, Drew's most likely going to click on this dashboard. So in spite of just going and clicking on it ahead of time, we are waiting to confirm, is your user journey going towards the dashboard? If that is the case, the bot would prepare the content even before Drew, the real user, the master, clicks on it. So your bot has prepared the content. So if it's SASE, then we have even cleansed the content with our security stack. And the content is ready for instant delivery.
So you're almost essentially prefetching sort of the most popular parts of a SaaS application for end users?
I mean, that's how we started, by the way. So you should really be joining startups with us, Drew. And then we learned with our customers. We understood that we don't want to just go and prefetch them based on popularity. We want to do them contextually. Because then I would understand that, hey, this person is most likely his journey is unfolding, that he's going for the report section of Salesforce. Whereas this journey is unfolding towards the dashboard. This person's journey is going for opportunities. And the bot understands it. So it contextually prepares it.
Is this context user-based or more organizationally based?
It's app-based.
App-based, okay.
So app-based, and then we contextualize that for this user. Remember, DrewBot only cares about Drew, right? So what it understands is, hey, this is how you are interacting with the application. So contextually, it understands your user journey and then maps that against the application behavior. So this is why we call this Ruby, which stands for Real User Behavioral Intelligence. So based on that, we are now the bot is able to understand what is relevant, and then it prepares. I like to call it compute the future, click quote unquote. So we just call it compute the future, which basically is the only way to break this, I would say, dependency, right? Because applications are getting heavier, and if you're going to be reactive, which all the applications are reactive today, then you have to pay what I call the latency tax when the application is busy doing the computation. So how do you help app makers who are pouring all their brilliance and resources to boost app experience if I can take that latency away by pre-computation? Now imagine you get all that amazing feature without delivery. In other words, when you walk into the restaurant hungry, you get your best chef's food instantly.
So these bots, are they being spun up sort of inside, say, an SD-WAN gateway or at the edge of a SaaS application? Where do they live, essentially?
Yeah, so the way we have designed it is we want to optimize SaaS applications for SD-WAN, and we have put this as a cloud-delivered application, cloud-delivered service. So if you're using SD-WAN, the brilliance about this approach is you don't have to beef up your SD-WAN boxes. We understand our customers have invested on all these SD-WAN boxes, but we want to deliver more and more value on those boxes without having to change the form factor. So we did all the bot in the cloud, so customers don't have to worry about their ION devices, but they can just wire to the cloud, and then we would do all the bot computation in the cloud, so customers don't have to change their infrastructure.
So does this then require me to also be tied into your Prisma SASE, or can I get this just with SD-WAN standalone?
You can get this as SD-WAN standalone. You can get this as SSC, Prisma Access standalone, or Prisma SASE.
I know, Subbu, this comes up a lot with customers with the standalone SD-WAN or even with SASE. We talked about the direct to app path. But some of our customers also ask us about branch to branch. So sometimes the app is not sitting in a data center, it's just sitting locally hosted at some branch location. So just want to confirm that this app accelerator actually works on all paths regardless of where it's destined.
Yeah, that's actually a very good question, Mitesh. So the way we want to really think about the app acceleration is wherever you are running your applications, we want that to go through the app accelerator. That way, you can actually boost for latency. Now, there is a second leg to it, which is boosting throughput. So in the ion to ion routing, Mitesh, I think that's an excellent point. Imagine if you have one ion device that's connecting to multiple apps and that's getting overchoked. Now our bots would understand where the choking point is occurring inside the customer's network. And it's going to actually inform us and our customers that, hey, these are all the congestion points that are distributed in your universe. And we will also say what users are using what applications and where the latency is getting pegged. So short answer is yes, Mitesh, we want to app acceleration to help all of them. And as customers want, and as we get smarter with what kind of problems our customers are facing, and as we get inputs from people who have field intelligence like you, I believe we're going to work together with the customers to make this better.
Okay, so there's a lot going on here. How do I, as a customer, am I getting reporting on this as a customer to see that these bots and all of this capability is performing as I'm hoping or intending?
Yeah, that's I would say is the most important thing. The way we want to actually help customers is we want to give them real-time insight into how users are distributed, what kind of problems your workforce is facing, and what kind of applications are consumed by different work population, subpopulation. So then with app acceleration, you can now internalize it and you can say, the workforce that's connecting to this ION device is exhibiting a lot of packet loss or packet corruption. Even though our app acceleration is compensating for it, you can now be more strategic and specific about how you want to take out those problems. So over time, your network is optimized for the kind of applications your users are using.
Fantastic. If folks are looking for more details about all of this, you can go to paloaltonetworks.com/SASE/app-acceleration. That's paloaltonetworks.com/SASE/app-acceleration. We'll also have other links in the show notes to more resources, including ebooks, if you want to get into even more detail. Thank you, Subbu and Mitesh, for joining us, and thanks to Palo Alto Networks for sponsoring Packet Pushers. Sponsorships ensure that we can continue to bring you deep technical podcasts, videos, and blogs for your learning and professional development entirely for free. Speaking of that content, you can find this and many more fine free technical podcasts in our community blog. It's all at packetpushers.net. You can hear us on Spotify, and if you would leave us a rating on Apple Podcasts. Last but not least, remember that too much networking would never be enough.